Greeting learners, so we're gonna continue our session. Today we will be taking exercise 7. Exercise 7, the first one is determine the sum to infinity for the geometric series given negative 27 plus 18, negative 12 plus 8, dot dot. So we're gonna start with the first one. Once we're done with the first one, then we'll go to the second one. Solution for the first one. 1. They want us to get the sum to infinity for this geometric series. We will start by getting the common ratio. Common ratio is going to be equal to 18 over negative 27. And this will be equal to negative 12 over 18. Then we use a calculator to get the common ratio. 18 divided by 27. Then we get negative 2 over 3. Negative 12 over 18. So we're getting negative 2 over 3. Negative 2 over 3 is our common ratio. So our first term, A, is equal to negative 27. So the sum to infinity will be equal to A over 1 minus R, negative 27 over 1 minus 2 over 3. This is being the common ratio. So using our calculator, what are we going to get here? So negative 27 over 1 plus 3 over 3. 2 over 3, sorry. Over 3. And the answer will be negative 81 over 5. Negative 81 over 5. So this is the solution for the first question. The sum to infinity of this geometric series is negative 81 over 5. So now we're going to take the second one, number 2. X minus 2 squared over 4 and x minus 2 cubed over 16 are the first 3 terms of a geometric sequence. 2-1, for which values of x is the sequence converge. So here I think we're going to correct the sequence converge. We will have to say convergent. The sequence is convergent. Yeah. Now, to get the value of x for which the sequences will convergent, we're going to consider the terms here. First, we're going to get the common ratio. It will be R is equal to x minus 2 squared over 4 over x minus 2. So this will be equal to x minus 2 squared over 4. This will be reversed, so we'll be having times 1, and here is going to be x minus 2. So our common ratio will be x minus 2 over 4. And then we know the condition for sum to infinity. Our common ratio must be between negative 1 and 1. So you'll be having x minus 2 over 4 between negative 1 and 1. We're going to multiply by 4. Here it will be negative 4 x minus 2 is less than 1. So x minus 2 is between negative 4, and here we multiply by 4. So it will be x minus 2 between negative 4 and 4. Solving this in inequality, x will be less than 4 plus 2, 6. The other side, it will be minus 4 plus 2, then we're getting negative 2. So our x will be between negative 2 and 6. This is the first sub-question 2.1. We're going to clean the board at the top here so that we'll have space for this second question. Yeah. So I'm going to clean the board here. This was for the first question. We are under question 2, solutions. We will take now question 2.2. Determine the sum to infinity if x is equal to 1. If x is equal to 1, we're going to replace here 1 minus 2. 1 minus 2 squared over 4. And the third one will be 1 minus 2 cubed over 16. This is our first three terms. So we'll be having here negative 1. The second one will be 1 minus 2 squared. We're getting 1 over 4. And the third one will be 1 minus 2 cubed. We're getting negative 1 over 16. Now, if we want to get the sum to infinity for x is equal to 1, we will need to get the common ratio here. Our common ratio will be 1 over 4 over negative 1 will be equal to negative 1 over 4. And if we consider negative 1 over 16 over 1 over 4, then we're getting negative 1 over 4. Then we will calculate our common, we'll calculate our sum to infinity. I'm going to clean the board here so that we'll have some space. Now, sum to infinity is equal to a over 1 minus r, with a our first term and r the common ratio. Our first term here is a negative 1, so s infinity will be equal to negative 1 over 1 minus, our common ratio is minus 1 over 4. So let's take a calculator. Here we'll be having s to infinity will be equal to negative 1. Down here we'll be having 1 plus 1 quarter, and it's going to get 5 over 4. So the sum to infinity will be equal to negative 4 over 5. If we reverse this, we get negative 4 over 5. Then we are done with the first two exercises under exercise 7. We're going to clean the board and take the third one under exercise 7. Okay, we're taking now exercise 7, number 3. The question is, consider the geometric series 45 plus 15 plus 5 plus ... 3.1. Does the sequence converge or diverge? Justify your answer. 3.2. Determine the sum to infinity of the series if it exists. Solutions. 3.1. If we want to see if the sequence converge or diverge, we will need to get the common ratio. So a common ratio here, R will be equal to 15 over 45. It will be equal to 5 over 15. And this will give us 1 over 3. And now, remember our common ratio must be between -1 and 1. As you can see here, 1/3 is between -1 and 1. So we'll say that the sequence converge because 1/3 is between -1 and 1. So this is the answer for the first question. Now we're going to take question 3.2. Determine the sum to infinity if the series, if it exists. So 3.2, sum to infinity, the formula is A/1 minus R. So our A is 45. Our common ratio is 1/3. So our sum to infinity will be equal to first term 45/1 minus 1/3. So it will be 45/2/3. And then using our calculator, I'm going to have 45/2/3. 2/3. And our answer will be 135/2. The sum to infinity is equal to 135/3. Sorry, I mean not over 3, is over 2. Yeah, let me double check. Is over 3. Then we get 135/2. Yeah, 135/2. Okay, I think we are done. This was practically the exercise under sum to infinity of a geometric sequence or geometric series. We are practically done with this. Thanks for watching. Don't forget to subscribe, like, comment, and share the video if you have learned something. Thank you. Bye. Yeah.